everybody, so today we're going to talk about using congruent triangles with CPCTC. So CPCTC stands for corresponding parts of congruent triangles are congruent. And so we're never going to have you memorize that, but just know that what that means is that if you have two triangles that are congruent, so for example, these two triangles here, right, they're congruent. And we know they're congruent because of angle side angle. So we can use the triangle shortcut to prove that ABC is congruent to PQR. And now that we know that this entire triangle is congruent to this entire triangle, if we know those two triangles are congruent, then any of their parts will be congruent. So we can use CPCTC as a proof reason to then say something like angle A is congruent to angle P. And that's because if the whole triangle is congruent to the other whole triangle, then their angles that correspond to one another must be congruent. You can say the same thing for segment AB and PQ. So AB right now is not marked congruent to PQ, but we could prove that using CPCTC. Corresponding parts of congruent triangles are congruent. So sometimes with CPCTC, we have to figure out which triangles do we even need to prove congruent in order to prove certain segments or angles are congruent. So sometimes there might be multiple triangles in the diagram. If we were trying to prove that angle 4 is congruent to angle 9, angle 4 is part of which triangle? So is it part of the blue triangle, the green triangle, which is this entire triangle here, or the yellow? Well, 4 is only part of the blue triangle. So in order to prove angle 4 is congruent to 9, I would need to first know that triangle ACD is congruent to triangle BCD. And if I knew those two triangles were congruent, then I can easily say angle 4 is congruent to angle 9 because they're corresponding parts of congruent triangles. Now, notice in number 2, it says which pairs, so pair or pairs of triangles should be proven congruent in order to prove AD is congruent to BD. So sometimes there are multiple triangles that will contain a certain side or angle. So in this case, AD, which is this segment here, and BD, which is this segment here, they are part of the yellow triangles, right? So AD is part of this yellow triangle and BD is part of this yellow triangle. So if I prove the two yellow triangles congruent, then that would allow me to prove that these segments are congruent, because if this whole triangle is congruent to that whole triangle, then of course the segments of that triangle would be congruent. However, AD is also part of the blue triangle. So that means that if I proved ACD, so this blue triangle, congruent to this blue triangle here, then I could say that AD is congruent to BD because they would also be corresponding parts of congruent triangles, this time the blue triangles. Okay, so let's try one more together. This one says which pair of triangles should be proven congruent in order to prove angle 5 congruent to angle 6. So angle 5 and angle 6 are part of the blue triangles, right? So right away we can say, okay, if ACD was congruent to BCD, if these two triangles were congruent, then I could easily say that angle 5 is congruent to angle 6. But angle 5 and 6 are also part of larger triangles. So which other triangles are angle 5 and angle 6 a part of? So angle 5 and angle 6 are also a part of the green triangles, ACE and BCE. So this entire triangle here and this entire triangle here. If I prove this whole triangle congruent to this whole triangle, then I could say that angle 5 is congruent to angle 6 for sure because of CPCTC. So this or this would be acceptable. Which pairs of triangles should be proven congruent in order for AE, so AE is down here, to be congruent to BE? So I'm going to let you try this one on your own. So it could be more than one. So select all that apply in order to prove AE congruent to BE. So this would be the green triangles could be proven congruent, or the yellow triangles could be proven congruent in order to prove that AE is congruent to BE. For number 5, which pair or pairs of triangles should be proven congruent in order for angle 1 to be congruent to angle 10? So how could I prove angle 1 is congruent to angle 10? Think about it. So this one was only ADE congruent to BDE, and that's because angle 1 and angle 10 are only part of the yellow triangles. No other pair of triangles contains those angles. Okay, so now if we were to use this in a proof, to use CPCTC in a proof, we would first prove the two triangles congruent. So we can prove triangles congruent, make sure you write this down, with AAS, SSS, HL, AAS, SSS. And so we could prove the triangles congruent using our standard shortcuts that we've been using since December. And then after that, the last step, right after the triangles are congruent, is your CPCTC step. And that can say that a pair of angles or a pair of sides that haven't been proven congruent yet, now we can say they're congruent because of CPCTC. So let's do one example together. So we have NP bisects MO. So that means MO is a segment that's being bisected. So if MO, the segment MO is being bisected by NP, that means that MP has to be congruent to PO. And so let's mark that. And this would be because of definition of segment bisector, because the segment is being bisected. All right, I'm also going to mark at this point that MN is congruent to NO. I forgot to mark that from the given information. So this was given to us. So now we have two pairs of sides that are congruent, this pair and this pair. And so now I need one more thing. So the last thing, there are actually two options, but I am going to pick NP being congruent to itself because I think it's the easiest one. And so if NP is congruent to itself, think about why that's true. So why is NP congruent to itself? And that's because of the reflexive property. So reflexive property tells us that's congruent to itself. After that, now I can say the triangles are congruent. So now I can say that triangle MNP is congruent to triangle ONP. And what would be the reason? SSS. So now that I know that the triangles are congruent, then I can say that any of their corresponding angles are congruent because the whole triangle is congruent to the other whole triangle. So now I can say, okay, well, that means that MNP would have to be congruent to ONP because these two triangles here are congruent, so these two angles of those triangles must be congruent. And the reason for that would be CPCTC. And that's it. So CPCTC should always be used after proving congruent triangles. All right, one last example. So in example 2, we have MO is parallel to NT. So that's already given to us, parallel. And they're also congruent. So the segments are parallel and congruent. And so if I have a pair of congruent segments, then that gives us one pair of sides. Now I need two more things. So the first thing I'm going to say right off the bat, because it's the easiest to see, is that NT is congruent to itself. So NT is congruent to itself because of reflexive property. Once I have reflexive property, now I have two pairs of sides. Now, in the end, I'm trying to prove that MN is congruent to QT. So if I'm trying to prove these two segments congruent, there's no way to do it without proving the triangle is congruent, because these two segments have like nothing in the given that would allow us to prove them congruent. So I first need to find something else so that I can prove the triangle is congruent. So let's go back to the given. We have MO is parallel to NT. So if MO is parallel to NT, then I'm going to go to my parallel lines reasons. So parallel lines, let's look for alternate interior angles because those are the easiest ones to see, and those are the most common ones you're going to see with congruent triangles. And we can see here that MQ, it's actually a Q, I call it an O sometimes and a Q sometimes. Oops. But anyway, so MQ is parallel to NT, so that would be these angles here. So angle QMT and angle MTN are congruent. And that's because of parallel lines imply alternate interior angles are congruent. Okay, great. Now I can say the triangles are congruent. So the triangles are congruent because I had two pairs of sides and a pair of angles that were congruent. So the reason would be SAS. So now that the two triangles are congruent, I can say any of their other pieces are congruent. So if I know that QMT and MTN are congruent triangles, then I can say that any of their parts are. So I can say MN is congruent to QT. And so MN is congruent to QT, and that is because CPCTC. And that's it. We're going to talk a lot more about this in class on Wednesday and Thursday and Friday.